Hi, this is Involved Innovation YouTube channel. In this video, we will see about least recently used cache programming problem with animation. This is a system design focused on one of the cache eviction strategy. In the least recently used cache, we will evict the least recent used content in the cache if the memory capacity is reached. This is a leetcode problem as well. The problem statement states, we need to design a class named LRUCache. The constructor need to get the capacity of the cache. We need to create two methods. One is get method, which takes key as a parameter and returns the value associated to the key if present. If the key is not present, then return -1. Put method, which gets the key and value as a parameters. If the key is already existing, then modify the value already exists with the incoming value for the key. If the key does not exist, then add it to the cache. If the capacity is reached, then remove the least recently used item from the cache and add this newly coming item to the cache. These two functions, get and put, must run in order of 1 time complexity. We will see the working of least recently used cache strategy with an example. First, we are defining the capacity of the cache as 2 in the constructor, using the put function to add the key 1 and value 1 to the cache. The cache is empty, so it is straightforward. Next, we are adding another entry, key 2 and value 2, using the put function. Since there is one empty space in the cache, we can enter this as well. Now, there are two elements in the cache. One is least recently used compared to the element 2, and we have reached the cache capacity. Now we use the get function to get the value associated to the key 1 in the cache. Key 1 is present in the cache, so we can return the value associated to it. So after this, key 1 is accessed recently, so 2 becomes least recently accessed compared to 1. Now we use the put function to add an entry, key 3 and value 3. Already the cache reached its capacity, so we need to evict an entry to add this. Entry with key 2 is least recently used, so evict that entry and add the entry with key 3 and value 3. If you use the get function to get the value for the key 2, you will get -1 since the key is not present in the cache, which we evicted to accommodate the entry with key 3. Use the put function to add the entry with key 4 and value 4. As the cache capacity already reached the limit, we need to evict the entry with the key 1, which is least recently used, and add this entry to the cache. Now the entry with keys 4 and 3 are present in the cache, where 3 is least recently used. We will try to get the value associated to the key 1. The entry with key 1 got evicted and not present in the cache, so we will return -1. Next, get entry with the key 3, then 3 becomes most recently used and 4 becomes least recently used entry. Next, we will get the entry with the key 4, then 4 becomes most recently used and 3 becomes least recently used entry. This is the working example of least recently used cache. Now we will see how to solve this problem. A key thing to note in this problem is the get and put function need to be executed in order of 1 time complexity. The intuition to this problem is we need to use 2 pointers. One to reference the most recently used side and one to reference the least recently used side. We can use the doubly linked list. Doubly linked list is a linked list data structure that consists of set of sequential linked records called nodes. Each nodes contain 2 references, one to point to the next node and another to point to the previous node, where the head side references the most recently used items and the tail side references the least recently used items. And we will use the hash map to find if the key is existed in the cache. In the hash, the key is entry key and then the value is the node. Node is the object which has key and value and references to the next and previous node. We will see the working of LRUCache with doubly linked list and a hash map. First, we will create a doubly linked list. Here we create 2 dummy nodes with key and value as 0. We will point this head's next reference to the tail and tail's previous reference to the head node. Hash map holds the key and value as a node reference. So we can use the hash map to check if the key exists currently in the cache. If present, we can get the node reference from there. We add the first entry, key 4 and value 4 to the cache. First we will check if the key exists in the hash map. No, the hash map is empty, so we will create node object with the key as 4 and value as 4. Then we will add this node right after the head. Get the head's next reference, tail, which we will be pointing to the nodes next. Now reference the heads next to this node and nodes previous to the head node. Likewise, reference this node's next reference to the tail and tail node's previous reference to this node. Now create a new entry in the hash map with key as 4 and value as node object. Now we will add the second entry, key 2 and value 2. We will check if the key exists in the hash map. No, the hash map does not have this key, so we will create node object with key 2 and value as 2. Then we will add this node right after the head. Get the head's next reference, which is node with key as 4, which we will be pointing to the nodes next. Now reference the heads next to this node and this node's previous to the head node. Likewise, reference this node's next reference to the node 4 and node 4's previous reference to this node. Now create a new entry in the hash map with key as 2 and value as this node object. Still the size of the cache is less than the capacity 4. Follow the same step. Check the key in the hash map, then add the new node 8 to the next of the head node. Now the size of the cache is 3, which is less than the capacity 4. We will add another entry 5 to the cache. Add this to the next of the head. Now we reach the capacity. If we check the linked list, head's next node is the most recent, followed by the next recent, and so on. Tail's previous node is the least recent node. Now we use the get method to get the value associated to the key 2. Check if the key exists in the hash map. Yes, it is existed in the hash map. Check the associated node and remove this node from the linked list and add it after the head node next. We have changed the recency of the node with key 2 and return the value associated to the key 2. Now we will add the entry with key as 7 and value as 7 to the cache. The cache reached its full capacity, so we need to evict a node before adding this node 7. Remove the tail's previous node. Then add this node 7 to the next of the head node and add the key 7 and this node to the hash map. Now we will see another example where the key is already present in the hash map but the value is changed. We add the entry with key as 8 and value as 6. First check if the key is present in the hash map. Yes, the key is present in the hash map. Next, get the node associated to the key 8. Change the value to 6 in the node and then remove this node from the linked list. Then add this node to the head node next. If you try to add the entry 4, the key is not present in the hash map and the cache capacity is already reached. So evict the previous of tail node and remove this key 5 and its value from the hash map. Then add this node 4 to the next of the head and add it to the hash map as well. Last, if we try to get the keys value which is not present in the cache, we can check if the key is present in the hash map. If it is not present, then return -1. Here the time complexity of put and get function is order of 1. Space complexity is order of n. That is because the maximum size of hash map is n and then the maximum size of linked list is n plus 2. So we can say the space complexity is order of n. Now we will try to implement this LRU cache class in Java programming language. We can follow the same pseudocode to write the program in any programming language. First, we will create the node class which has the integers key and value to represent the key and the value of the node. Then two node references, one to point to the previous to this node and another to point to the next of this node. We have the LRU cache class which has global variables such as size to store the current size of the cache, capacity to store the maximum capacity of the cache, head node reference to point to the head of the doubly linked list, and tail to reference the tail of the doubly linked list. In the constructor, we are getting the capacity as the parameter. We are creating a dummy head and tail node with key as 0 and value as 0. Link the head's next reference to the tail and tail's previous reference to the head. Initialize the size as 0 and assign the capacity to the class instance variable. Here we are assigning the capacity to 3. First, we use the put function to add the key to and value to. In the put function, we are checking if the hash map contains the key to. Hash map does not contain the key to. Check if the capacity of the cache is reached. No. Then increment the size of the cache by 1. Create a new node with key as 2 and value as 2. Add this key and node to the hash map value. Next, use the add node function to add this node to the doubly linked list. In the add node function, reference the node 2's previous reference to the head and this node's next to the head's next, which is tail. Next, you need to reference the head's next, which is tail. Reference the tail's previous reference to the node 2 and node's next reference to the tail. Now we will add another entry with key and value as 5 and 5 using the put function. Check if the hash map contains the key. The key is not present in the cache. Next, check if the capacity is reached. No. Then increase the size and create a new node with the key as 5 and then the value as 5. Use the add node function to add this node to the next of head node. Similarly, we will add another entry with key and value as 7 and 7. This is not present in the hash map and the size is less than the capacity. So create a new node with key and value as 7 and 7. And link this node to the next of head and then add this to the hash map. We have reached the capacity in the cache. Now we will use the get function to retrieve the value for the key 2. Check if the key 2 is present in the hash map. Yes. Then get the corresponding node from the hash map. Then using the remove node function, remove this node from the doubly linked list. In the remove node function, it gets the previous and next reference of the node to remove and then link this previous and next. Then add this node 2 to the head's next. So we have increased the recency of node 2. Now we will see what happens when we try to put a new entry when the capacity is reached. First, we will check whether the key is present in the hash map. The key is not present in the hash map. So we will check if the size reached the capacity. Yes, the size reached capacity. Both are at 3. Now we will remove the tail's previous. The tail's previous is 5. So remove that node and then remove that node from the hash map. Then create a new node with key as 3 and value as 3. Add this to the next of head node. Now we have removed a node to accommodate this new node 3. Next we will see what happens when we try to alter the value of a key which already exists in the cache. For this we will use the key as 8 and the value as 6. First we will check if the map contains the key 8. Yes, it contains. Then change the value of this node. Here already it holds the value as 8. Now change it to 6. After that, use the remove node function to remove this node from the doubly linked list. Then use the add node function to add this node right after the head's next. And we will check another condition where we will check what happens if you get a key value which is not present in the hash map. Now if you try to get the value for the key 9 which is not present in this cache. So first we will check if the map contains the key 9. The key 9 is not present, so we are returning -1. And this is one of the highly asked question if you are preparing for coding interview or system design, and if you want to learn more on the computer science topic, subscribe to this channel. Thanks for watching.